Yes, it is. Okay. Similar polygons, same as similar triangles. Some of you might feel like you already knew this. So the angles are the same, and the sides are the same. So if we look at this first example with two parallelograms, and parallelograms have always the opposite sides the same, in this case, you can see that you can double the smaller one to get to the bigger one, or you could take the bigger one. If you went backwards, it would be half as big. So if you go from left to right, this would be a reduction. If you go from right to left, it would be an enlargement. And since the scale factor is multiplied by 2 on all four sides, we can say that these two shapes are similar. Here we drew two rectangles. We used a scale factor of 1.5. The smaller one and the bigger one then are similar because all the angles are the same and the sides are proportional. Now for labeling these, did you get that MAH? This was the 80 degrees. MTH, that's this one, 100. And AHT is 110. MA is 6. TH is 4. MT is 6.3. AH is 5.8. And ST is 4. Now, we need to find all of these angles, labeling it on here. So whatever we figure out, I'm going to do in blue. Did you figure out that if they're similar, the angles would be the same? So now if I wanted to angle TSO, that will be 70. TPO, this one is 110. POS, that one's 100. And PTS, that one is 80. Then for the sides, what's happening here? Well, it needs to be something that you multiply. Yeah. Right? If I want to figure out what I'm multiplying by, right, you can either go this way or this way. Some people like to always go from smaller to bigger because then they're always multiplying by something bigger than 1. So if I go from 4 to 6, can you see that you're multiplying by 1.5? Okay? That means going backwards, you would have to divide by 1.5 to undo that. Dividing by 1.5 is the same as multiplying by 2/3. But I find that people like to go from the smaller one to the bigger one. Can you see, if you take 6 in your calculator, divide by 4, you get 1.5. Okay? That would tell you that's how you go from the smaller one to the bigger one. Dividing by 1.5 would move you backwards. So you take out your calculator, you go to the other sides, 4 divided by 1.5. This will be 2.67. 5.8 divided by 1.5. This will be 3.87. And 6.3 divided by 1.5 will give us 4.2. So now that we've labeled our sides, we can go to the chart. S to O, that's my 4.2. T to P, that's my 3.87. And O to P is 2.67. All right, so this next question. You're looking above down at a castle where a dragon lives. The castle is in the shape of an octagon. And then they make a bigger octagon around it, filling it with water. Each side of the moat measures 3 meters. So this side is 3, this side is 3, this side is 3. It's pretty, yeah. It's a very small castle. And it says that the moat is 1.4 times. So if I went from this side here to this one, I need to multiply by 1.4. It is a very small castle. It's a tiny dragon. Right? So now if we wanted to find, this side was multiplied by 1.4 to get 3. So if you wanted to go backwards to find the actual side of the castle, you'd have to divide by 1.4. So I go 3 divided by 1.4 on my calculator, and I get 2.14. It is a very small castle.
Wait, couldn't you do it at the end though? Like times 3 by 8 and then you get 24 and then you get divided by 1.
You could. You could. So I figured out one side, and then the perimeter would equal 8 times 2.14. So I go to my calculator, I go times by 8. And this is a great example. Because if I go to my calculator and do 2.14 times 8, I get 17.12. The actual answer is 17.14 because I rounded early, okay? And what Nevaeh is saying is if things are similar and we're dealing with dimensions, the perimeter of the moat is 8 times 3 is 24. And if you take 24 and divide that by 1.4, you will also get 17.14 meters. Yeah, that is a very small castle. It's about 2 meters by 2 meters by 2 meters by 2 meters. About the size of probably of your room. And we are done the unit. Woo! So, we'll stop the video here.